Okay, measures of central tendency. This video might be a bit interesting. I just ate a muffin with peanut butter in it, and I don't have any water, but I'm sure it will be fine. Okay, so measures of central tendency, we've got three. We've got the mean, median, and the mode. Okay, the idea of these measures is to tell us what is a typical value or what represents the whole set of data. So someone might say to me, how well's your Maths B class going? I would say, oh yeah, about B's or something like that. Or about A's, hopefully, after this exam. Okay, so three different ways we can give one number to represent a whole group. Okay, so the first one is the mean, which a lot of people will talk about when they talk about average. So we'll put in brackets here, average, okay, but it's not good enough just to say the average score is whatever, okay, because we need to be more precise. We've got these three different averages. Okay, to find the mean, we'll add the scores together and divide by the number of the scores. The symbol we'll use is X bar, okay, and X with a line on top, okay, called a bar. Okay, that's our mean. The median is the middle score when the data is in ascending order. Okay, the score is in position number n plus 1 and 2, where n is the number of scores. Yep. Okay, and the idea is that that'll mean that 50% of the data is above the median, 50% is below. The mode is the one that occurs most frequently. Okay, we can have many modes bimodal, or there can be no mode. Okay, mode probably isn't used as much in most statistical analysis. It's probably most popular in elections when we're just wondering which party got the most votes. So we'll have a list of votes like Liberal, Labor, Liberal, 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 Labor, Labor, and we'll just see which one occurs most often. Using numerical data, especially continuous data, we typically won't have any modes. Alright, so let's have a look at a bit of a problem. I want to find what the average house price is in Waterford using a sample from realestate.com.au. I live pretty far away, thinking of moving into Waterford. So yeah, I'll have a look at some house prices. Okay, so I've got a sample of 6 pieces of data, and I want to calculate the average. So I'm going to calculate all 3 averages. So first of all, I'll calculate the mean, the X bar, which I'll do by adding all these scores together. I bet this is entertaining. And divide by how many scores there are. 1, 2, 3, 4, 5, 6. And I'll write here n equals 6. Okay, it's just calculator time. You should probably do it yourself as well. Make sure you use some sort of brackets or the fraction line that you have on your calculators. Okay, put all these ones on top. And divide by 6. Yeah, that's an interesting price. Press my fraction to decimal button. So the mean price of a house in Waterford, just using the data I took as a sample, is 507,333. Okay, and notice that in the mean we used all the scores. Okay, it used all scores to calculate mean. Yeah, there wasn't any scores were excluded or didn't really pay attention to, used all of them. Right, so let's have a look at the median. Okay, so at the moment that 500,000, I'm just a poor teacher, I've got no chance. I'll look at the median score. So put the data in ascending order. So the cheapest house was 375,000. And I just have to rearrange them so they're in ascending order. Again, this is quality YouTubes. For bigger lists, I'd recommend that you, like, once you've written the number, maybe put an underline under it so you know that you've used that one and you don't repeat it and you don't miss some. Okay, that's a tip for beginners. All right, so I've got those 6 data points. My median is the n+1 on 2th position. Okay, so I know that n equals 2, correction, n equals 6. So the median will be wherever n+1 on 2 is. So wherever 6 plus 1 on 2, I'm looking for the 3.5th score. So this is the first, this is the second, this is the third, this is the fourth, this is the fifth, this is the sixth. I'm looking for the 3.5th, so I'm looking for the one that's in between these two. Okay, so in this case, median will be the average of these two. Okay, looking for something exactly in between these two. So add them together, divide by 2. Or if my fraction key works properly. No. Okay, so that's the total, divide by 2. Okay, 420,000. Okay, so we're going to discuss the difference between these two, but just before we do, I'll see, is there any mode? Is there any score that occurs more often than others? No. Okay, there's no mode. Okay, so for future generations, I'll probably make sure that there actually is a mode. Okay. So, which one is the better measure of central tendency in this scenario? Which one better represents the cost of houses in Waterford? So if we look at the mean, 500,000, that's supposed to be like an average value representative of all the houses in there. But only this one is above that mean value. Okay, so what's happened is the rest of these scores, the rest of these prices are pretty much the same. But then we've got this dude that's decided to build some ridiculous mansion with a big swimming pool looking over some valleys. Okay, so this house, because it's so different to all the others, okay, is called an outlier. Okay, which basically means really different to the others. Okay, so we have an outlier in our data. Okay, we've identified it. We'll look at tests of how to identify outliers in the future, but we've just identified that that there's an outlier there. Okay, so what that outlier has really done it's affected this mean significantly. Okay, it's made it a lot bigger than it would be if that house wasn't there, if he was just a reasonable person and didn't want to show his wealth off to the world. Okay, if we look at the median, okay, we haven't actually used every single data point. Okay, if this person's house, if he decided to build a skyscraper there and make it worth 9.5 million, the median's still the same. But if he decides to, I don't know, put a space station there, put a few more zeros there, and the median's still the same. The median won't change. Okay, so which is a better measure of tendency in the scenario? I'd probably say in this case the median is better. Okay, and the reason is because of the existence of outliers. Okay. The existence of an outlier. And that outlier, that really big house, has inflated the mean price significantly, where it doesn't really represent the data that well. So typically what you'll find is that the median is preferred over the mean in most cases, unless we want to use the mean to then say, well, if I want to buy the whole town of Waterford, how much will it cost me? In which case the mean would be the one. Okay, for certain applications, but typically the median's better when there's outliers. If there's no outliers, mean and median are normally pretty close together. Okay, so our notes. So if there's outliers, we'll use the median. If no outliers, okay, it doesn't really matter. And we can use our graphics calculator to check our calculations as well. So I'll get my graphics calculator out, go into the menu, into stat mode, and I'll type my data in here. I type all my data in, just into the first column because it's individual data. Okay, I want to do a calculation. I need to make sure it's set up correctly. So these first two lines need to look like this. Okay, the x values in list 1 and frequency of 1 for all of them. Okay, from here I can press 1 var for my calculation, and I should have all of my statistics here. So where is my median? My median price is 420,000, which agrees, and my mean is this one at the top, 507,333. I think it also gives me a mode. Okay, see how it's listing every score as a mode. Okay, it's like there's 6 modes. Okay, so make sure you write down notes on how to do this. Put it all in one column. Press set, ensure it looks like this, list 1 and frequency of 1. And you'll be practicing that in some of the exercises. Another way data can be presented is in a table. Okay, for example, a table of weights. Okay, to calculate the mean, median and mode on here, there are heaps of methods to do it manually, but it's not that important anymore. Okay, we're more just interested in how you can use your calculator to interpret the results. So for these types of problems, need a midpoint to represent these different weight classes. So between 40 and 49, we're going to just average these two, okay, and say that those 4 people that weigh in between there, we're going to say on average they weigh 44.5. Okay, we'll do the same thing for these 2 spots. Okay, and we're off to our graphics calculator once more. So I'll delete all of these scores. I need to put only these 2 columns into my calculator. Okay, the midpoints and the frequencies. Okay, so I'll write a note here. This is list 1 and this is list 2. Okay, from here I'll go set. The only thing that changes now is this frequency needs to be list 2. Okay, so we're only playing with those top 2. When the data's in a table, list 1, list 2. When the data's individual, just a 1 there. Okay, exit out. Always one variable statistics. Okay, and I can just identify mean, median, and mode here. So my mean is 54. My median is 54.5. And my mode is 54.5. Okay, so it says it's 54.5, but I'm going to just recognize that it's really a modal class of 50 to 59 kilos. Okay, so there's my mean, median, and modal weight. So you've basically got 2 skills. You can calculate mean, median, and mode from individual data manually and on graphics calculator, and you can calculate it for tabulated data using your graphics calculator. Have we got some of these? Okay, maybe the first couple before class, and in class we'll be discussing the news, like pretending that we're adults. Okay, bye.